Let's go a little back in history. For centuries, scrolls have been made the same way and even been made using the same tools. I got this picture out of a reprint of an old book that was first published in Paris, 1767. And you see scrolling forks like this guy here. It looks pretty much like the one that we teach. And you see a scroll jig here. It looks pretty much like what we teach. So I thought this was pretty amazing when I saw that in this book. And then the other side page, I found this grill here. That's a couple hundred years old. And I'm not sure if they called that a level 2 grill, but it's awfully close to what we call a level 2 grill. And see this guy here, he's using a scroll jig to make this scroll, and he has the tools, the same that we use. Here is the first ribbon scroll. And what I did on my drawing is I made a mark here in the middle and used that as a reference point. And I measured my stock that I started with and then put it on here. That way I could calculate how much stock it would take to make this scroll. In my case, it was 16 5/8 of the parent stock. So when I go and then do the other end the same way, I know I need to cut this at 16 5/8 from this point to the end. And then if I do the same scroll on the other end, then it will fit my frame. Hopefully it will. So for now, I will use this piece that I just made as a master to make a scroll jig. If you make a lot of scrolls the same way, you can speed up the process by having a scroll jig, because the hand scrolling of larger scrolls takes a lot of time if you all make them freehand, even if you are used to do it. If it's just a little scroll, you can just eyeball it and get it very close. But if it's bent around like what we are doing here, it's very hard. And the scroll jig can either be made, and that's what I will show here, from thicker material. This is 3/8 by 1 and I think 3/8 by 1 I used. Or you can use quarter material, but then you have to weld it to a surface, otherwise it will not hold up. I enlarged this picture from this old book here. They used this version, but they for sure couldn't have welded it. So I'm not sure how they made this. It looks almost like there's a rivet in here and a rivet in the middle, but I don't know that for sure. And the text is very, very hard to read. It's kind of like an old style of German, and I speak German, but it's very hard. So I don't know how they made it. One thing to show here, this end is flared, it's wider. And that's because it's curled around more than 360 degrees. And if this would not be flared, you couldn't get the scroll started. All right, how do we do this? We draw out the end of the bar, make it wider, and offset it to one side. You see the upper line here is straight, and this is not. Then we curl it around, and we continue using a bending fork to do that. And we don't need to be very careful to do that. We just have an approximate shape of what we will end up with. And we use our master scroll, the ribbon that we had made before, and finish it like that. I show you how that works. Here is what we will have at the end. And to not bore you with my hammering here, I speeded this up by a factor of 2. So I get this wider in the front. And what I do is I start in the middle and then go back and forth I made a little mark here how wide I want to be at the end. And I do some more with the second heat. I flared it out to about 1.5. And then I thin the end a little bit. And then make it one-sided. There we are. Same that we saw before, just a little faster. We scroll it around over the edge. We make it about to fit. So we go little, curl it in a little more, go a little more, then go with the bending fork. And just roughly give it a shape that is a little too small for what we want to do at the end. So see if this fits in there. Yeah, it does fit in there. That's all we need. The fit is very loose, but this is all we need. Now we take a good heat, make it very hot, and put our master in the vise, our loose fit into it, and then now we just hammer it into it, and you see how it goes around and fits pretty nicely into it. When I first did this thing, I was really amazed how easy this was. I got a little gap here. Now I use the fork that I don't have even yet because Russ hasn't made it. And tighten it a little bit there, and that's it.
Okay, so I'm Russ Evertz. Yeah, so the same as what Frank was saying, these are called scrolling forks, bending forks, scrolling wrench, dog wrench. They have lots of different names, but that's what we're going to talk about today. I'm going to get fancier than what Frank was with his U-shape. He was gracious and only showed his a few times. So the features that we need on a scrolling fork are that we need it to have smooth jaws. That's just so that we don't mark the face of our work when we are scrolling. We can choose whether we want to have tapered jaws that we can get into tighter spaces, and those will work better for organic shapes. And when I'm saying tapered jaws, I mean the width of the tines as well, like a scrolling tongs. So that way you can make the tines real close if you want to bend the stem of a leaf or something. And then for regular scroll work with square stock or rectangular stock, we want to have parallel jaws. So that way we can keep this in one plane, since most of the work that we're doing is in one plane. This picture kind of shows a lot of times it might be easier to leave both scrolling wrenches with the tines pointed up so you can see what you're doing better. The high level steps are, we need to forge the front tine, the one on the end here. Then we need to isolate the second tine, reduce our handle so we have room, and then we upset the second tine. Then we can bend our first end tine there and then square up the jaws, and that's basically it for the business end. So this is everybody's favorite part, is the calculations in blacksmithing. I know you guys all want a blacksmith so that you can do math, and then the fire is just the added benefit. So you can either phone a friend, call an engineer, but I'm oftentimes busy. You can do the math, or Victoria did this a little bit when she was working on the poker. So I changed mine, and instead of redoing what she taught, I'm just switching to this block method, which is just to visualize how this could be made up of a predictable size of blocks. So that's the method I'm going to use. It might work better for some people to visualize this than doing the math. And once you sort of see something one way, it's hard to get it out of your head. So then you just start seeing everything as a collection of cubes instead of actually for what it is. So the scrolling fork dimensions, we're going to be using 3/8 stock that starts out as 1 inch thick. And then we're shooting for a 1 inch tine length. And for this demonstration, I'm doing a 1/2 inch, which was probably a bad choice retrospectively because it's a little tricky to get that bend real tight. I should have picked an easier one, but that's comes into the question Victoria answered, which maybe if you have a 1/2 or 3/4 or 1 inch or maybe 1.25 inches, that's that jaw width that we're talking about. And then if you can keep the body about a 1/2 inch thick, then you'll have enough strength to keep your fork from bending while you're bending your scroll. So that's this is kind of the target dimensions. So this method to break it up into blocks, you're basically just shooting for 1/2 inch by 1/2 inch blocks, since that's what the dimension our stock is here, and we have a 1/2 inch gap. So we end up with all of these little blocks. I just call this one a 1/2 inch by 1/2 inch block for simplicity. And we're all of the scrolling fork is going to stay at 3/8 of an inch. So we're not going to worry about the volumetric dimensions. We're just going to worry about the 2-dimensional because everything else is going to stay at that 3/8. So we don't have to do anything to address that. So the first thing, if we want to reduce this tine down into a square shape, we can just rotate this tip down, and that gives us a perfect 1/2 inch block, which we've talked about it several times before, and a lot of blacksmiths probably know the height of our triangle is actually 1/2 of the height of the triangle. So that is where we get this height of a 1/2 once we're done. So we started at 1 inch and then we condense it into a block and we get that 1/2 inch by 1/2 inch. And then we're going to need to know how to forge this before we put all of that taper. So we need to first have 1.5 inches long by a 1/2 inch high chunk of metal there in order to make our tine and get our bend and get our jaw. So first we have our jaw, we have our bend material, and then we have our tine material. So hopefully this isn't confusing people. So the second thing we need to do is we need to figure out if we want to make a 1/2 inch by 1.5 inch block of material isolated for that jaw and tine, what do we need to do to get that into the parent stock size? So our parent stock is 1 inch wide. So here we're 1/2 inch wide. So to change that into, condense it back into 1 inch wide, we just cut that in half and stack it up. So we had 1.5 inches here, and now we just move that. So we have 3/4 here and 3/4 here. So we end up with 1 inch high by 3/4 stock. So that's what we're going to have to forge down in order to get this rectangular portion here, and then later our tapered tine. So just kind of as a reminder what we were shooting for, we were shooting for a 1/2 inch jaw. And in order to get that 1/2 inch jaw, we're going to use 3/4 by 1 inch. If you'll remember last month, that every time we go to do a half face blow on our anvil, we end up having our metal creep along. I guess we're doing the near side, so it'll actually start climbing towards us. So we start with something and we want to end up with 3/4. So if we start with an 1/8 inch bigger at 7/8, then as that stock creeps back, by the time we're done, we'll end with that 3/4 that we're looking for. So we're going to add an 1/8 inch to that. And that is what we're going to mark our anvil. You saw Frank marking his anvil. Here, I'm going to mark it as well. a lot of times if we mark our steel, by the time we get it bright orange and get it out of the forge, we can't see that mark very well. So if you can, it's easier to mark your anvil, and you can use that as a reference point to start that half face blow. That's why we do the 7/8, even though we calculated it at 3/4. So here's where we're gonna mark it. We're gonna start low when we do our first blow, so that way we can set this shoulder. If you don't have this set low, when you set that first shoulder, you don't end up with a sharp point because you don't have the concentrated blow of your anvil corner, and it'll be harder to hold that firm. So as we're forging it, we're going to be pushing this into the anvil the whole time, and that's going to keep this corner static in the same spot. This shoulder here has that 1/8 of an inch that we talked about. So now we just keep that. You can see every once in a while it bounces out of that step, and now I'm lifting my metal up. And there I was forging that corner back into the piece so that it doesn't get those fish lips that get over the top. And then as you go, you can address that growth in width. As you're going along, you'll end up with some growth here. It'll mushroom out to the side. So you need to make sure that you address that as you go. If you let it go too long, you can fold this corner over inside and end up with a cold shut. So make sure you address that as you're moving along. So once we get that 1.5 inches, then we're going to go ahead and taper the end of the fork. We want about a 1 inch taper here, and we want our total length to be 2 inches. This is where we need that anvil block to protect our anvil, because our hammer is going to hit our face if we do that. Or you can also use the Hardy, especially if you have a square corner of your hammer that you can drop into your Hardy, or you can do it over the horn, which is, at the beginning, my block was too wide even, so I had to switch to the horn. So then we're going to isolate that second tine. And I think at the beginning, before I had done this and I had seen other people do it, maybe not in real time, I thought this seemed like a crazy idea, but it ends up going a lot quicker than what you might think. So we're going to use this material right here to make that other tine. So if you remember back to that block visualization, we needed a 1/2 inch by 1/2 inch block, and we can tip this up and we'll end up with our 1/2 inch tine. So that says that we only need a 1/2 inch of material. Unfortunately, the math is not really right. I don't know why it doesn't work. There's some material that goes into this radius here and some material that goes into this radius here, but we end up needing a lot more material there. So this is a reason why you also need to do test pieces, just to make sure that what you're doing is actually grounded in reality. Once again, we want to have about 1 inch of material here, but that's going to creep out 1/8 of an inch. So we're going to use 1 1/8 inches to account for that. Same steep first blow as well. And this time I'm actually pulling against that step so that I can keep that corner crisp. And then addressing the width. Now that time I was cleaning up those corners to try to combat those corners flaring out before it even started. So if you need to make a little bit more room, we don't need to reduce our entire handle just yet. We're just trying to get room to have to make room for our fuller. So you can also use the horn of your anvil here, and that'll speed up that handle reduction. So before you move on to your next heat too, since this thing is getting so bowed, you want to make sure you get that kind of straight, so when you come out of the forge hot, you're working with straight stock. That's generally almost always the case. If you go into the forge with straight stock, that way you can be more efficient when you're at your hottest. And generally it doesn't take much to straighten stock because we're not forging the section down. This is probably the most iconic part of the scrolling fork, and the skill that's probably the best learned with this tool, and that's upsetting this tine. You can either use an angle or just weld a piece of flat bar here, and then you need to have this radius. You can't tell, this is, I think, radius a little bit more than what it's showing right here, but you don't want to get a cold shut right there because you have a sharp edge, which is what your vise may be giving you. And your vise is also going to be typically less than 90 degrees. So you might have that angle might be getting too sharp. As we move, well, this says punch, but it's actually supposed to be your fuller. So as you're driving that fuller in there, you want to stay closer to vertical than 45 degrees. And this is where I never made a handled tool for this, but this is probably a good spot for a handled tool because your knuckles will get a little toasty. You can tell this is my portable anvil instead of my one on my bench. And now I'm fullering those corners in as I go so that they don't get out of control and end up folding over later. So I would say I might be at about 22 degrees or something, halfway between 45. And then you can also switch to your cross peen and your flat face as soon as you start getting down here. And you can see why we want to have that narrow portion of the handle so that we have clearance for that fuller. Now I'm just taking care of those corners so that they're not sticking out. So here's where we're at. We end up getting our tine forged out. And this is the best time to radius these faces. So you remember this contact point right here is going to be hitting the faces of our scrolls. So we want to make sure we get this radiused as well. And then also down in the crotch of this jaw here, that's going to be touching the outer edge of our scroll material too. So we want to kind of radius that and soften all these edges. By the time you get this bent to a 1/2 inch, you can't hardly fit a file in there at an angle to radius this. So it's a lot easier now when you can hot rasp it. We're going to move on to our next step, which is bending that tine over the horn. We have this sectioned up regions or model so we can really see. This was our jaw region. This was our bend and our tip. So we want to make sure we center this spot right here over the horn. And then we're going to quench our tip so that way we can protect that, because we're going to need to hammer right down on that to tighten that corner up. I think this tine is a little bit too long. It gets shorter as you set it down though. So it ended up being only about 1/8 of an inch too long, which you probably want it to be longer than shorter if you're gonna err on one side or the other. So then once we're done, we can set this jaw down onto whatever stock we're shooting for. So we're shooting for a 1/2 inch. So we're gonna set this down on a piece of 1/2 inch stock in our vise, and that's been dressed a little bit. So these insides are rounded, so that way we don't end up with a sharp transition on the jaws, which could reduce its life later. And then set that down and then push these jaws in so that they're parallel. If those jaws aren't parallel, when you go to bend those around, you're gonna end up kind of corkscrewing your scroll as you go. So that's kind of an important step there. So that's basically what we're shooting for. So this is, you can see this is just a little bit wide there. So it didn't end up being too wide, too long in the end. And you end up crumpling this tip a little bit. So it's nice to not have that coming to a point anyways. So that's the end of the business end of the 1/2 inch jaw. I know you guys were asking about the different sizes. So here's if we're looking at some other sizes of jaws and kind of what that would look like, figuring out what kind of material to forge down, and then what type of length we need that tip to be. So if we had 0 opening, we would end up needing a 1/2 inch of parent stock because we have this 1/2 inch block that's 1 inch wide. If we were to go for a 1 inch width jaw, then we have these 2 blocks right here, 1/2 inch by 1 inch. So that's the additional parent stock that we're going to need. So that adds an additional 1/2 inch of length to our parent stock. So for a 1 inch fork, we're going to need a 1/2 inch for the jaw parent stock and a 1/2 inch for the tip, the fork on the tip. So that's going to be 1 inch total. And then remember, when we mark that out, we're going to mark it at 1 1/8. So that way we can combat that 1/8 of an inch shift. So if you're only going to look at one slide for this whole presentation, this is probably the best cheat sheet for you to have. So this tells you kind of the sizes. So for half inch, we're going to need 3/4 inch stock. So we're going to mark that at 7/8, and then we're going to forge the rectangular portion that's 3/8 by 1/2 inch out to 1.5 inches, and then additionally we'll forge that to a point. So these are the square ends that we're going to do. So 1 3/4 for 3/4 inch, 2 inch for 1 inch, and 2 1/4 for 1 1/4. So then, just so we can get more math into it, I have this quick slide to talk about the handle. So if we wanted to put a handle, one of the sort of the ABANA requirements, one of the things says technically that you should have a scrolling fork with a round handled end with a fixed diameter. So this is kind of how to meet that requirement. So we can pick the diameter. We're going to pick 3/4 of an inch inside diameter, and we're going to make this loop out of 1/4 inch round stock. Once again, review from last month, the neutral axis is the portion of any structure, beam, or member that does not have any tension or compression. So the length doesn't change. So this outside part will be stretching, this inside part will be compressing, but this dotted line here is going to stay the same. And that's for a circle that's in the middle of it. When you start getting into other crazy sections, it moves around. But that's going to be 1/8 of an inch here, plus 1/8 of an inch here, and 3/4 of an inch. So that gives us a total of 1 inch. It's basically your stock diameter plus your inside diameter. So In order to find that circumference, we'll use pi times the diameter. So that's 3.14 times 1. So that gives us 3.14, which I've done this thousands of times, and I still think that sounds crazy that you'd need 3 inches to make a loop like that. But we are going to subtract a little bit because we already have some material here, so we don't need to make that portion of the circle. So we're going to call this 3 1/8, which is 0.125. So if we subtract that, then we get about 2 3/4 is what we need for our stock length. So we go ahead and forge that down to 2 3/4 with 1/4 inch diameter. We're going to bend this into a hockey stick first, not quite 90, a little bit open, but that, while we can get in here, you can't do this very well later after you've started your loop. So we'll do that first. After we do this step, then we're going to bend the tip later or secondarily. And finally, in the end, we're going to bend the middle. So that'll get us to our turned eye, and that will be 3/4 inch ID. And then if you want to case harden your scrolling fork, I don't know that case hardening is that helpful on scrolling forks, but it is helpful, especially on bottom tools and other things. It basically just puts a shell around your mild steel that has a higher carbon content. So it'd be like sort of like the eggshell around a boiled egg. You know, instead of just being soft and mushy mild steel, you'll have this stiffer shell, and it's supported by the mild steel underneath. So to do that, you heat your stock up to 1600, and then this is a powder that contains carbon and a bunch of other things. And then you reheat that up to red again and quench it in water quickly. And that will harden up the surface. And you can actually get a scale to skate on mild steel by doing that. So when you're done, don't forget, especially that's kind of one of another feature of the ABANA program is to try to get people to have a nice fit and finish on all of their stuff, which means trying to remove all of your loose scale and then apply some sort of finish. If you're handing this over to somebody that's going to be judging your work and seeing how you're going to do, it's nice to go the extra mile to have a finish on it, which is the same thing when you're handing anything over to the public or to one of your clients. It's nice to have a finish and to get that scale off of there just to raise the bar for all blacksmiths. I think that's about it for my portion.
No, this is just a thought, and I can't 100% prove it, but the way that you hold the piece in the vise is very similar to the way you do a half face blow. So you're going to get some material creep as you try and upset that second tine. And the front tine usually grows in length a little bit, which I think yours came out an 1/8 inch longer. It's probably
Right.
where that material came from. It's because it's shifting down in the vise just a little bit.
Yeah, pushing everything up. So you're actually forging on the anvil side, which is your vice jaw,
Yeah.
like your hammer side. Yeah, that could be. You're just actually pushing that whole thing up. Sure.
So you'd lose a little material there, and then to the radiuses, and then because you're not coming to like an infinite point, the math,
Right.
It's an 1/8 inch here, a 16th inch there, and it starts to add up pretty quickly, especially if you're not using any dies or anything to make sure that you're going back exactly to the parent thickness.
Yeah, right. Yeah, it just doesn't look good when you're saying you need a 1/2 inch and I'm telling people to lay off 1 inch and 1/8.
Right.
Listen to the math here and ignore it over here.
Thanks for watching, and be sure to check out the rest of the series.